1. These are the basic level questions. And the first thing you should ask yourself is, are there any greatest common factors? Well, there's no greatest common factors for the first two, but for the last one, they both have a common factor of 2 and x. If I write them out in prime factors form, they both have a 2 and an x, so that can come out of the parentheses, and I'm left with x plus 3. And you could check by distributing. If you distribute that back, you would get 2x squared plus 6x. So that's your answer for C. It's only one set of parentheses, because that was a binomial. Now for these other two, they are trinomials, and if they are factorable, to get the 1x squared, they're both going to factor with an x and an x to start the two binomials. So you can use the shortcut to just find two numbers that multiply to the constant term and add to the middle term. So if I'm thinking of all my factors of 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8, and they have to multiply to a negative 40. So that means one of them is going to be positive and one's going to be negative. And they have to add to a negative 3. So that means the bigger of the two factors is going to be the negative. And then I can see that this is the answer. So a plus 5 and a minus 8. Doing the same thing for B, factors of 30. 30 divided 2 is 15, 30 divided 3 is 10, 30 divided 4 is a fraction, 30 divided 5 is 6. And this time they need to multiply to a positive, but add to a negative. So when that happens, they're both going to be negative. So if I do negative 5 and negative 6, they will still multiply to positive 30, but they'll add to negative 11. Moving to number 2, these would be more of the meets/exceeds type of level. So the first thing I'm going to do is I'm going to look for any GCFs. No GCFs for A, none for B. Looks like there's probably one for C. Looks like I can factor a 3 out. Because if I divide all of these terms by 3, I get x squared minus 3x minus 40. And right away, if I remember to do that first, now it's a much easier problem because just like the last ones, the leading coefficient is 1. So it's going to factor this way. But just don't forget to keep that 3 that you factored out in front. And then finding two numbers that multiply to negative 40 and add to negative 3, well, I think that's the same two numbers we had before, negative 8 and 5. And it doesn't matter if you put the x plus 5 first and then the x minus 8 second. That would be fine too. So now the other two don't have a GCF, and the leading coefficient is not 1. So another shortcut I can use is look for perfect squares. So I'm looking at this first one. Are the first and last terms perfect squares? Well, they are, because the square root of 9x squared is 3x. And the square root of 25 is 5. So when that happens, my first terms of my factors are going to be those square roots, 3x, and the last terms are going to be 5. And then to multiply to a positive but add to a negative in the middle, this is negative, I'm going to have a minus and a minus. And in order for that shortcut to work, this middle term has to be double the product of those. So it's double 3x times 5, which is 30. If that didn't work out, then this wouldn't be the correct factorization. But remember, you can always check by multiplying this out and see if you get the right answer. You get your 9x squared, negative 15x in 2 spots, that's your negative 30x, and your positive 25. So I can do the same thing for this one, because 49x squared is this is 7x times itself twice. So the square root of 49x squared is 7x, and the square root of 9 is 3. So it starts and ends with perfect squares, but you'll notice there's no middle term. So when that happens, you have to have 1 plus and 1 minus. Because if you multiply this one out, you'd have a 7x and a 3 and a 7x and a negative 3. You get your 49x squared and your negative 9, and then in these other two spots, you get negative 21x and positive 21x, which cancel. By the way, I forgot to mention this. Another way to write the answer for part A is 3x minus 5, the quantity squared. So that's what the quantity squared means. You're taking something and multiplying it by itself. The last two, I'm going to start them the same way. I'm going to look for a GCF. The first one has a GCF of 4. Because 16x squared divided by 4 is 4x squared. And 4 divided by 4 is 1. And this is a common mistake. A lot of people forget to put the 1 there. They just say, oh, it cancels, it's gone. You still need the 1 there. Because remember, if we distribute this back, we should get 16x squared minus 4. I don't see any GCFs for part B. After I factor out the 4, I realize that I have perfect squares. The square root of 4x squared is 2x. The square root of 1 is 1. And there's no middle term, so just like the last one we did, it's going to be 1 plus and 1 minus. And this is your final answer. Now, if you had, instead of factoring out the GCF first, recognize that these are also perfect squares. The square root of 16x squared is 4x, and the square root of 4 is 2, and gotten this, it is factored, but it's not completely factored. Because you could still factor another 2 out of each of those. And then this becomes 2 times 2 is 4, times 2x plus 1 times 2x minus 1. So you get some credit for factoring, but you wouldn't get full credit because you didn't completely factor. Now the last one does not have a GCF, does not have a leading coefficient of 1, does not start and end with perfect squares. So what I recommend you do is use the box method to factor that. And when that happens, you're going to put the first term and the constant term in those corners of the box. That's step 1. So that's just coming from here. Step 2 is what I call the magic question. So find 2 things that multiply to this product. You multiply those. 8 times 5x squared is 40x squared. But also add to that middle term, negative 41x. So you're going to think of all your factors of 40. Always start with the factors, the things that multiply. So 1 and 40, 2 and 20, 4 and 10, 5 and 8. If they multiply to a positive 40 and add to a negative 41, they're both going to have to be negative. And you can see the first pair there. A lot of people forget the factor of itself and 1. But that's the answer in this case. Negative 1x and negative 40x add to negative 41x. So you fill in the box with those two. It doesn't matter which one goes where. And then our last step is to take out the GCF from each row. I can factor out a 5x, just a 1, just an x, and an 8. And now this is a little bit unusual situation. If we check by multiplying, we get our 5x squared and our 8, but we wouldn't be getting these negatives in these 2 corners. So what we have to do is make these both negative so that we get the negative 40x and the negative 1x, but still maintain the positive 8. Because a negative times a negative is a positive. So that tells us our answer in factored form is 5x minus 1 times x minus 8. Any questions on the test examples?